All right. So welcome everybody to our live event introducing AI for image analysis, how to be successful. Today is day 2 of the event. Before we start, and to allow everybody to arrive, I will give you a quick walk through the Zoom window in case you didn't attend yesterday's webinar. You will find at the bottom of your window an FAQ button in which you can enter your questions or comments during the event. During the presentation, we will answer your questions at the end of the session, so please feel free to ask, to comment, give us some feedback, please do so during the course of the event. So that's it for the technicalities. I will start today by first introducing myself. I'm Anne-France Carter and I'm a marketing specialist at PreciPoint. I'm here today with our speakers. First, let me introduce my colleague, Birgit Müller, who is the head of business development. She's here today with us, and she will be for the rest of the week. And I welcome again Mr. Philipp Kainz from our partner KMLVision, based in Austria. Philipp is the founder and CEO, and here he is with us today to share with you again on using artificial intelligence. Right, so as I mentioned, today is the second day and part 2. Before we start, let me just allow me to share my personal takeaway from yesterday's session. As we looked yesterday into how to get ready for AI. So what needs to be in place before you start using AI software? And personally, what struck me was when Philipp said that to be successful with AI, you need people and data. And somehow that resonated with me for various reasons. I don't think we need to discuss this now, but I found this interesting, and maybe we can come back to this at the end of the session if there is any interest from the audience and if there is some time. But today, our topic is defining your requirements for an analysis solution. So we will look into what precisely do you need to consider when you're looking for AI software. Because they're not all the same, but you need software that suits your needs. So this is the topic for today. And now I have the pleasure to hand over to Philipp, who will now give his presentation to you.
Thank you, Anne-France. So welcome everybody, also from my side, to part 2 of this 4-part series we're doing with PreciPoint. Today is about choosing the right analysis solution and defining the requirements. And what this is all about, I will show you in the next couple of minutes. For those of you who weren't in the webinar yesterday, a brief background and introduction. So my name is Philipp Kainz. I'm the CEO and co-founder of KMLVision. My background is in biomedical image analysis involving machine and deep learning. I did my PhD at the Medical University of Graz and worked on histological slides of the bone marrow, where I decided it would be interesting to provide the pathologists with some decision support tools. And not only in the academic world, this was of high interest to me. I founded KMLVision together with my co-founder to provide these intelligent and accessible solutions for an efficient automation of these labor-intensive tasks that we are most of the time facing when using big image data, and histology and pathology is a very dominant example of this problem. So we decided that it makes sense to put all this technology into a product, and we developed the COSO platform, which is a collaborative software tool for large-scale image analysis. It consists of both a data management, a data repository where you can annotate and share your data, and the automated analysis part where you have ready-to-use AI models to apply to your data, or you can also train your very own AI. And the use cases are quite frequent in the biomarker analysis, in cardiovascular research, in regenerative medicine, and also tissue engineering. So yesterday, Birgit from Point talked about the challenges of slide digitization and how their microscope can actually accelerate you to unlock the digital world and apply AI. But as any different technology that you introduce newly into your system, adding AI to your workflow involves changing your process to a certain extent, but it allows you to scale your image data analysis. Another takeaway was that you should start thinking in digital workflows and recognize and acknowledge that this is an iterative process, and it involves many stakeholders, as Antoine already mentioned. So building up know-how in your organization, in your team, using a minimal workflow allows you to grow with the task and make it a sustainable impact also in your organization. And finally, a recommendation is that you should work with industry experts that help you overcome initial challenges and avoiding pitfalls. We also talked about a checklist for AI readiness assessment. And starting with the whole slide imaging hardware, you also need IT infrastructure and viewing software to essentially be set up for doing any kind of automated image processing. And to enter the world of AI, you then need annotation and labeling software to create the data sets that you need for AI training, as well as the necessary training and prediction infrastructure. So let's not forget that there's also these people involved in the process, the stakeholders, at any step of the AI model development and evaluation. Finally, to get the most out of it and put the AI effectively to work, you also need to think of integrating it into the production IT environment. So approaching AI may seem quite challenging, especially if you did not yet work with it. So today I'm going to talk about some essential requirements to choose the right solution. Let's just record it. The goal is that we want to offload tedious work to machines, and that this can be achieved by a high degree of automation. To start with, there are both factual and technical requirements you should consider. The first are factual requirements that need to be formulated by domain experts, for example, which should be people acquainted with the use case. For instance, biologists and pathologists, so more or less the end users. They don't necessarily need to have too much knowledge of the technical implementation of AI, but of course, it helps to grasp the main concepts and understand what it takes to build an effective AI algorithm. So choosing the right solution depends on your prerequisites and requirements to implement AI. First up, it needs to be defined what exactly it is that you want to detect in the slides. So this is mainly driven by the research question you're trying to answer, because it will significantly determine the technical approach to solving the problem. Is it an area, or is it individual objects, or do you actually know what you're looking at? So these are questions that need to be answered first. Second, is it possible to find objective criteria that describe the image content? So usually during the requirements analysis, you should be able to articulate the criteria based on which you take your decision when looking at the image. So it's also clear that these criteria may be based on your own decision and your own experience, or your long-standing experience to automate. But to automate the image analysis, we must be able to get an idea of which information is actually significant. So this may be the signal intensity of individual cells when you use IHC stains, or nuclei density or shapes in the context of other tissue compartments. I will get back to that later, why this is important. The third aspect is to think about how you would like to be presented the results of this solution for your final decision. There's a wide range of representing qualitative and quantitative data using visualizations. And for example, it may be sufficient to get a compressed report on cell counts or something like this, and how confident the decision of a model in a certain area is. But you won't necessarily need to be sitting down and examine the entire slide and check for exact locations of a few thousand cells. That makes no sense. Finally, think of a minimum performance level that you want to observe. So in some cases, sensitivity is more important. For example, if you think of Helicobacter pylori detection, or for other use cases, a few missed objects are not of that high relevance. And then there are technical requirements, which are deducted more or less from the factual requirements. And that means the biggest risk of failure is not choosing a particular deep learning architecture or machine learning algorithm, but actually wrongfully specifying what you want to detect and how to set it up. And in general, it revolves around how you support training and evaluation. And it involves these questions that are shown here. So basically, which model is best suited for the expected use case? There are many algorithms and not all are part of the deep learning domain. Do you have sufficient data to train a deep learning model? And that's actually a tricky one, because how much data you actually need depends on the complexity of the problem. The less complex it is, the less data you will need. And for example, we have trained image segmentation models only with a few images, and this was only possible because the data was really available in a high quality. So the fact that deep learning in general is quite data hungry, you may want to consider the fact that all this available data may not be right from the start available to your use case. So you may think about a technique called data augmentation. Basically means that you create several versions of your image, and we'll also see that in a bit. You should be sure that if you go for deep learning, that you have GPU servers available or use platform technology that allows you to leverage this hardware acceleration. And another important aspect regards to the operation of an AI system, which is usually triggered by organizational and technical circumstances. So for example, is my organization allowed to use cloud resources, or the technical part would be, do I even have sufficient bandwidth to transfer the data? So you see that choosing the right solution depends on factual and technical requirements. So to match the requirements with image recognition terminology, let me show you some examples how AI can be implemented for image recognition. The first one would be image classification. So it's basically answering the question, which classes are present. We use it in categorization. You can apply it, for example, to individual objects. You can, in images, you can apply it to the whole slide. You can apply it to just regions of interest. And the next type of problem, how you can formulate it, is object detection. So which answers the question, where are individual objects of each class? Then this is frequently used just in counting and determining ratios. The next would be semantic segmentation, which answers the question, what is the shape or area of a particular class? So you can use it for area measurements of all objects that belong to a certain class. And then there's instance segmentation, which you may want to do if you do object-based morphometry, such as the nucleus segmentation. So to get started with AI, it's important that you define the use case and the objective. So essentially figuring out which readout parameters you want to have in the end, and if there is software that already supports it or not. So in general, you can build any pipeline from scratch if you want, but there are some solutions out there that already support what you need. So let's use prostate tissue as an example, where we can define two different objectives. The first objective is Gleason grading. So we are interested in how it distributes over the biopsy, and this would be an application for classification or semantic segmentation. So both ways would be possible. In the second case, we intend to characterize the adjacent normal tissue. So here we are interested in a low-level morphological feature analysis of individual nuclei. So we would opt for instance segmentation. So this choice also influences the requirements and which solution you should go for. So let me also briefly talk about training data augmentation as an essential step in creating robust AI models. Training data augmentation is basically the process of synthetically creating additional labeled training data instances for the AI. On a high level, this serves three purposes. So first, to increase the variance of how an input image may actually potentially look in the wild. So we want to realistically represent the data during training. Second, to simply add more training samples to give the AI something to chew on. And finally, balancing the training data, so which naturally not all desired objects may be represented at an equal frequency in the training data. So to avoid that the algorithm learns only the most prominent objects or class, data augmentation is frequently applied to balance this data. In the first image, we see that the original data or the original image has some characteristics, and we apply during data augmentation some random transformations in the spatial and color domain, such as flipping, rotations, also spatial transformations like this elastic deformation. So we want to create something that is a little different, but has the same semantics attached to it as the original image. So this random transformation can be parameterized. So it makes sense to know in which range it operates close to what you would observe also in the real world. And these can be twisted or should be twisted in a really careful manner before the data becomes unrealistic, because this wouldn't really serve the purpose, but only confuse the model during the training process. And another strategy is to overcome this limited data problem in the histopathology domain is using pre-trained models. So that essentially means that you can take a model that has been trained on a different yet similar task. So if you want to apply a nuclear segmentation model from H&E stained breast tissue, you may also use an existing algorithm that was pre-trained on prostate tissue. So it may not perform as good as training the original use case, but reusing these features that the model already learned can save you a lot of time and during data annotation, and to get to similar, sometimes even better results in less time compared to training a completely new model. So we have also heard about the requirements and frequently used strategies to use as a guidance selecting the best solution. So, however, the solution is only complete if you actually use it in production and you have it at your fingertips. So the final step to do that is deployment, and this can be considered from both the technical and organizational perspective. Technically, it's software, and it can run on a local machine, in the cloud, or an on-premise data center. Even hybrid solutions are available. And there are many tools out there that operate on your local machine, but if you consider the high amount of data, the large files, your local computer may not be fit enough to handle these files, and let alone processing them in a reasonable time to create value for you. So the second aspect is organizational policies, which may or may not allow either deployment option. In general, these two questions guide the practical usage of how to deploy AI to production. So first, how much data do you have? Is it feasible to actually transmit it over the net, or is it better to have a local installation if you have local data centers? So one thing I want to mention is that you probably have seen in your favorite news platform or even on social media is the term superhuman performance of AI. What that actually means is that AI is able to achieve a better performance for certain challenges than humans do. But these humans, they are considered the best at it. So many of these statements describe AI being used in playing games, or also for natural language processing and image recognition. AI has made tremendous progress in recent years. But for instance, AI models have shown to achieve a higher accuracy than a human on the so-called ImageNet database. And the ImageNet database is used for benchmarking these classification models. It consists of, I think, over 20,000 categories, and with over a couple of hundred images per category. So this kind of amount of labeled data is really a luxury that we don't usually have for any practically relevant use case in histopathology. And I presented some practical strategies on how to combat these issues. However, we have to recognize that AI already makes much more reproducible decisions than humans, and that the future will definitely rely on AI as a companion in your daily routine, as we do right now when using a computer to fast and accurately compute or calculate the morphological features of a cell. And therefore it makes definitely sense that you get acquainted with how to use this technology to your advantage as soon as possible. So the key takeaways I want to share with you today is that picking a use case and defining the objective very thoroughly, understand your factual and technical requirements will save you a lot of headache. And you should iterate over your ideas to implement AI with your peers. So if you define your targets, your research targets, talk to your peers if it makes sense. Is there really a way to describe a certain property objectively, or is that something that you would just use in language? Anything that can not be objectified in a sense that AI can learn it will probably have a hard time automating this in the pipeline. So match your requirements also with the advantages and limitation of available technologies to choose your right solution. So as I said, sometimes even the organizations have some policies and limitations that force you to go either way. There is no magic solution to arbitrary image analysis challenges. So AI will help you in many, many ways, but it's not the way that you are getting out of the picture. So there's always people and data and AI. And of course, you need to be frank that not all challenges are economic to be solved by AI. So if you would just like to use it, make a double check, please, the requirements, if that makes sense. Otherwise, you will end up frustrated along the way, because it wasn't really a solvable use case yet by AI. And finally, we talked a lot about the requirements and the challenges to establish or choose your solution. Many of these challenges, they are already implemented in existing platform technologies and solutions. So you don't need to start from scratch, but speaking at least some parts of this language will help you to proceed in the journey to implementing AI for image analysis. So this concludes my talk. Next, we will talk about how you can actually develop your own analysis, talk about some challenges and best practices. And yeah, with that, I thank you for your attention and look forward to the Q&A.
Thank you very much, Philipp. I will now take over your screen again. And while I do this, I invite the audience to post their questions now so that we can start the Q&A.
I think we already have 2 questions lined up.
Very good.
If I'm going through them, thank you as well from my side, Philipp. I think that was really, really interesting. Quick takeaway from my side was also those of you that have followed a few of the webinars that we have done previously, also around how to digitize in microscopy. We have talked a lot about the problem already of knowing what you actually want and aligning also within your team that you all want the same thing, right? And I think it just goes through in the exact same way with AI. It's important to align within the team before you start reaching out to providers at best. What is it that you want? What do you want to achieve with this? And what's the analysis that you would want to digitize and automate, right? Because otherwise you will just end up in also disputes internally around whether you achieved the goal or not. And that's not where you actually get more efficient from, right? So keep that in mind to do that. Now, the first question that I have from the panel, and please feel free to keep them coming, is how much do I need to invest to find out if I can solve a problem using AI? How do you see that, Philipp?
That's actually, I think, a very, very good question. So we try to provide very early in the process, whether you, when you decide whether to use AI or not, we decide to keep or to provide tools and solutions that can easily be accessed and tried out at a very low cost. So usually what I recommend is also early in the process, maybe even you don't need to be exactly sure how to solve the challenge, but get involved with an AI provider, talk about what you're trying to solve, and then they will be happy to assist you with choosing the way of least resistance, because there may be some similar cases they already encountered during their work in the market, where they learned how to solve a specific challenge. And this can really accelerate how you approach this topic. So I can really put a time or a price tag on how much I can, or how much you need to invest. It takes some time and resources that I already mentioned in my first talk, but it will be well invested. And even if you say, okay, we don't have any use cases that are economic to be solved using AI, because in the end, of course, there's a price tag and you need to balance whether there's a business case or if it creates enough value. But to help you figure out whether this is or not, this is the case, I think many of the companies have consultancies exactly for that.
Yeah. From my side, what I would like to add is, of course, I mean, we have discussed it yesterday. Having an image, a digital image, is the first thing, right? And unfortunately, there are still different file formats out there. So look into that before you reach out to, or when you reach out to a provider, that they can actually work with those files that you achieve from your scanners, or at least figure out whether they can implement these files in a way or another. Then, of course, also look into whether you can scan to the magnification that you need in order to see the objectives, the objects on the slides that you do want to see. And then, last but not least, of course, the image quality is not only determined by the objective you have in, but also simply by the scanner quality. And if you do not achieve a very good image quality, every AI will have trouble, or will only be, limitedly accurate, because it might be, guessing, and it might be the right guess. But if the quality is not good, so that's also something you should think of, and it could end up in investment, both in money and in time, as in wasting time to actually get to the right quality that you need. Yes, so much on this question. Then I had one more, that is, will we talk about an example that can be used in a pathology routine, or also in a cytology environment, like a pap test? Philipp, what's coming up next?
Okay. This we don't have any. So I didn't prepare any cytology related use case for the last talk. The use case also David Herche will present on Thursday will be in the histology domain of peripheral nerves. He will present how they approached the entire process and the challenge, because they weren't really able to solve or measure within these large images before using AI technology. So maybe in general, it doesn't make so much difference whether you apply AI to a routine or a clinical a research or routine use case. It basically has the same considerations at its base.
Good. And I think, Alphonse, do we have time for one more question?
So we have reached now the end of the webinar, but we still have the audience with us. So I would say yes. Let's answer the last question and make everyone happy.
Perfect. I will try.
We'll close up.
It's a little hard for me now to choose which one is the right question to choose to make everybody happy now. But I'm choosing maybe the one that Philipp has already touched upon a little bit to develop that a little bit further. And that is, can I actually apply AI to any use case I want? Does it make sense to do that?
You rephrased the question. It may not make sense, but you can. So I hope this talk inspired some of you and triggered some considerations to take when thinking about whether you can or you should. So these are two different things. It also may be determined on how much time you can really afford in going into that process, and maybe there's some chance for you to team up with others to create more value by choosing a use case that shares similarities, and you don't need to do it in this group and in that group and in that group, but to pool your resources and learn as an entire organization from the progress.
Absolutely. Super good conclusion, Philipp. I think this is also where I would see it going, right? I think it's very important to develop further and to figure out what more use cases can be solved. But I think it's also equally important to reuse them and not invent the wheel new every time. Take the work that others did already and rely on it and build on it, maybe, right?
Exactly.
Very good. So I think that's it from the question side, to not be too much over the time.
Yes, that's it for the question side. It's been very interesting, and I hope to see you tomorrow for the next topic, where we will look at developing your own analysis, some challenges and best practices, again with Philipp and Birgit. So if you haven't registered, you can find the registration link on our website, precipoint.com. Just find the webinar page in the top navigation and you'll get there quickly. And feel free to contact our speakers in the meantime if you have any further questions. We are here for you. And with this, I thank again very warmly Philipp and Birgit for this very interesting session today. And I wish you all a very nice rest of the day. And I will see you tomorrow.
Perfect. Thank you. Bye-bye.
Thank you so much, everybody. Bye-bye.